Hi guys, today I like to talk about math or critical thinking. Now, students at year 4, 5, and 6, they hardly ever have a chance to think about mathematics in a critical way. Um, but the idea here is that if you want your child to become a genius, to become a master in whatever they do, if they want to do mathematics, they want to do science, or whatever they want to do. They need to have real critical thinking. Now, math is a very interesting area because it trains students to be thinking in a way that is absolutely right, logically right. And so today I want to start the series with something pretty obvious, and you will find it interesting. Okay, so the topic of today is why is a straight line between the 2 points is the shortest distance? Okay, now have you ever asked yourself this question? Has ever teacher, have talked to you about this? The chance is no. They just say, oh, it's so obvious. You have 2 points, A and B, and you draw the line between A and B, and that will be the shortest. They never bother talking about it. But the thing is, if you talk about critical, you're thinking, you talk about real mathematics, you can't talk that way. You have to prove beyond doubt that the distance between the 2 points, the straight line will give you the shortest distance. And today, I'm going to show you how to do that. Okay, so back to the question, why is a straight line the shortest distance between 2 points? Now, the first thing I'm going to do is to draw a straight line. Now, so guys, first, I'm going to mark down 2 points, and I draw a straight line connecting between the 2 points. Here, I have point A, and here I have point B. Now draw a straight line between A and B. All right, so now we have the line AB. Now the next thing I'm going to do is I'm going to introduce a point C. Now, then I draw from A to C, and I draw from C to B. You see, if I can prove that I go from A to C and then go from C to B, the total distance is going to be shorter than go from A to B. Then I prove that the idea is wrong. But for any point C, if I cannot prove that I can go to C first, then go to B, and the total distance is shorter than going from A to B, then it means A to B is going to be the shortest, right? So this technique is called the proof by contradiction. So what I'm trying to do is for any point C that is not on the line AB, if I go through point C and I cannot get the shortest distance, then A to B must be the shortest. So that is the idea. And that is what I'm going to do. Now, how am I going to do that? I am going to use the concept of a circle. Now, the first thing I'm going to do is I'm going to draw a circle with the center at A, and the radius is AC. Now, it's not a perfect circle, but you get the idea. Okay, so now you look at it. The circle will cut the line AB as a point, and I will call it C1. Here, the point C1. Okay, next I'm going to do the same thing. B will be the center of the next circle, and the radius will be BC. Now, that's not a perfect circle, but good enough to make the point. Now, you say that it will cut the line AB at another point, and at this point, we'll call it C2. At this point, we'll call it C2. Okay, so now let's have a look. Got the mathematics, okay? So we have AC plus with CB. Now that will equal to AC1 plus with C2B. Now you see that AC1 plus with C2B is greater than AB because the line AC1 and C2B actually overlap. It overlaps right here. The overlap. Therefore, AC1 plus with C2B is greater than AB. Yeah, so we have proved that. If we travel from A to C and then C to B, the total distance is going to be greater than going from A to B. So, we have successfully proved it. Now, for any point C, anywhere that is not on the line A, B, this will happen. So, is it proven? AB is the shortest line. So, we start this whole series with a very simple question. Well, I hope that you enjoy it. Now, in the future, if I see an interesting, problem, I see something interesting, I will add into the series.